tangents in parametric. Say we have a following situation. We have a parametric curve given by x equals to cosine cube t, y equals to sine squared t. We want to find the slope of the tangent line to this curve at the point when t equals to pi over 4. Let's see why is that not too difficult. Recall that the slope of a tangent is equal to the derivative at a given point, so we need to find the derivative. So first thing, we need to find what is dy dx. So to define dy dx, we need to figure out what dy is and what dx is. Dx is straightforward to find, it's derivative of x, which is in our case going to be 3 cosine squared t times negative sine t dt. Dy is also straightforward to find because we know what y is. So dy will be derivative of y dt. So derivative of sine squared will be 2 sine t cosine t dt. Now that we know what dy is and we know what dx is, we'll substitute dy for dy. So we can try down 2 sine t cosine t dt. We can substitute what dx is. So that's 3 cosine squared t times negative sine t dt. Notice that dt and dt will be cancelled out. Sine and sine will be cancelled out. 1 cosine on top and 1 cosine on bottom will be cancelled out. So we found an expression for derivative dy dx. So it's going to be negative 2 over 3 cosine t. And then slope of tangent line, all that we have to do, just take our derivative and substitute given point, in our case, given t equals to pi over 4. So we're going to get negative 2 root 2 divided by 3. That's the first example. Find the slope, intercept, equation of the tangent line to a polar curve, which is log spiral r equals e to theta at point where theta equals to pi over 2. So what we're going to be doing in this problem, we're going to treat that polar curve as a parametric curve. So recall that x equals to r cosine theta. So in our case, we're going to have e to theta cosine theta. Y equals to r sine theta. So it's going to be e to theta sine theta. So we're going to treat x and y as a parametric function, both dependent on parameter theta. So when theta equals to pi over 2, x is going to be equal to cosine of pi over 2 is 0, so 0. And when theta equals to pi over 2, y is going to be equal to e to pi over 2. That's a point. Now to find an equation of a tangent, we need also a slope. Recall to find the slope, we need to find derivative. So we need to find dy dx. So let's find dy. that is going to be using the product rule, e to the theta sine theta plus e to theta cosine theta. Theta. Also can find dx, so we're going to find product rule again, e to theta cosine theta plus minus e to theta sine theta d theta. So we should be able to find derivative dy dx. So it's going to be equal to e to theta sine theta plus e to theta cosine theta divided by e to theta cosine theta minus e to theta sine theta. So slope of tangent line is going to be derivative at the instant when theta equals to pi over 2. So we're going to substitute pi over 2 to expression for derivative. I recall that cosine of pi over 2 is 0, sine of pi over 2 is 1. So we're going to get e to pi over 2 on top, negative e to pi over 2 on the bottom. So we're going to get slope of tangent equals to -1. So we know slope of tangent. We also know the point. So we should be able to write down equation over line. So we're going to get y minus e to pi over 2 equals to negative x minus 0. So the slope intercept is going to look like ey equals negative x plus e to pi over 2. So that will be a slope intercept equation of a tangent line to a polar curve.